Hello, everyone. This is Shambhavi. Thanks for taking out the time to attend my session. I'd also like to thank folks at Women in Tech. This gives me a chance to talk about two of my most passionate topics, product and machine learning and AI. And I don't think I can start without acknowledging the fabulous times that we live in context to machine learning. There is such a high appetite to invest in machine learning and AI to drive innovation and meaningful business outcomes. And my goal today is to help you unlock your product growth using machine learning and AI. But this journey can be overwhelming, especially for someone who doesn't have background in this domain. So my goal today is to help you unlock your product's growth using machine learning and AI. And for that, I have synthesized my experience in launching machine learning products and synthesized it and made it simple to be consumed in a duration of 30 minutes. So let's get started. So a little bit about me. I started out as a software engineer before pivoting into product. And in my product journey, I have launched features in companies like Groupon, Home Depot, and Amazon. Currently, I'm bootstrapping my own startup with a mission of helping people take lead in their tech careers. Over the course of my product journey, I have launched products and features that use machine learning in both consumer and B2B world. I started out at Home Depot, where I launched product recommendations powered by machine learning to present the right product in front of the customer at the right time. I later worked in Groupon's push marketing team, where I own messaging system that enabled us to send personalized messages across different marketing channels, be it push notifications, emails, in-app messaging. And later I pivoted into B2B world, where I used machine learning to solve a very unique problem of classifying products, billions of Amazon products, into industry standard codes to help our enterprise business customers create and manage their procurement policies. And last but not least, I drove Alexa's data services platform that delivered ground truth data in an on-demand and a scalable fashion to help our speech recognition and natural language understanding models. So here's the agenda for today. The first thing that I want to share is a 5-step framework to unlock your product's growth using machine learning and AI. Here we'll talk about how do you really identify an opportunity, assess the fit with machine learning, and then how do you define the requirements and ultimately execute flawlessly. The second part would be evaluating if your use case is a right fit for AI and ML. And I think this is critical to make sure that you don't fail at the later stage of your whole ML product lifecycle. The third part is the AI and ML concepts that you should know as a product manager. I would also be highlighting things that you don't need to know, or you should rather lean on your data scientist for that. And then the last thing, I think, which is the most favorite part of mine, is something that you can do today to get started. So let's start with the 5 steps to unlock growth. The first step is to start with the goal metric and build your hypothesis. Now, this step is important irrespective of whether you are using machine learning or not, but I like to start with this step to make sure that we are always focused on the customer and the goal or the business problem that we are solving, as opposed to just focusing on the machine learning and the technology aspect. So let's use example for this. Let's say you're in charge at LinkedIn and you have to identify an opportunity and launch a feature that would use AI and ML and drive products growth. So for this, we usually start with what are the output metrics. So for LinkedIn, there are 2 types of output metrics. One is the subscription revenue that LinkedIn earns through Sales Navigator or the LinkedIn Learning. And then the second bucket is the ad revenue. So let's break it down into what are the actions that you need to do to drive these output metrics. So if you look at subscription revenue, things that you can do to drive that are help find leads and candidates for recruiters. Or the other thing that you can do is have good selection and quality of the courses. If you look at ad revenue, you can enable, you launch tools that enable creators to create high quality content quickly. Another thing that you can do is enable or launch features that help conversations on LinkedIn, wherein people can reach out to their to other professionals to help them or in the job search. So let's say that your product area is related to enabling conversations. So let's break it down. And so if you break it down, you have 3 input metrics. One is reply rate, the conversation depth, which essentially means how many back and forth conversations has happened between 2 individuals. And the last one is the number of sends. So let's say your goal metric is the reply rate, and you want to do something that increases the reply rate. So once you have your goal metric, you need to think about the AI and ML opportunities that will help you drive that goal metric. And for that, ask yourself these 3 questions. The first, are there any repetitive manual steps that involve simple human judgments that, if applied on massive data, will help drive your goal metric? The second is, can you use wisdom of crowd to come up with smart suggestions or recommendations that will help either reduce the steps that a user has to take or reduce their cognitive load and make their experience better and help them do things, make it more likely for them to do things. The last question is, are there any patterns in the data that, if exploited, can help you reduce cost or save time? So when you think about these questions in context of the goal metric that you have, you should try to come up with a hypothesis that will help you drive the goal metric. Let me give you an example, right? Let's take our LinkedIn messaging example. And if I think about that, I think there is an opportunity where I can use the wisdom of the crowd, which is past historical conversations, and create some sort of a smart replies feature that will help me or help the users increase their response rate, because it'll be easier for them to respond. So for example, this is what I'm talking about. So if someone reaches out to you over LinkedIn messaging, and if the platform shows you 3 different options using which you can respond back, it will help to drive up the reply rate, which is our goal metric. And in order to do so, we can use the machine learning by using the historical conversations and the wisdom of the crowd that we have. So with all this in mind, our hypothesis becomes, if we show smart replies on the LinkedIn messaging platform, then it will drive up the reply rate because of ease of use. So this is how I want you to think about creating your hypothesis. Now we come to the step 2. So you have your goal metric, your hypothesis, and now you have to come up with that that key question for your machine. And this is important because the type of question that you ask will dictate what ML technique you will be using. So let's first understand what are the type of questions that the AI and ML system can answer. There are 4 types. The first one is, if your hypothesis or your use case entails asking a question like how much or how many, it falls under something called regression. An example is, if you want to predict a price of a house given a ton of other factors like number of rooms, the neighborhood, school district, and things like that. But if the crux of your question is how many or how much, it's a regression problem. The second type is, what is that? Is it A or B? In this scenario, you're asking your machine to classify an entity. It could be product, user, movie, anything. But you are asking it to classify it into a particular category. An example is, if you want your machine to classify the email into a spam or not a spam category. The ML technique that you are using is classification. The third category is related to detecting objects. So your question here is, where is it in this? And a lot of applications for this type of machine learning is in computer vision space. So for example, if you are a car rental company and you want to automate detection of any damage when a vehicle is returned, and you want to use machine learning for that, the key question that you're asking your machine is to detect any damages in the vehicle. So this is called detection. The last one is when you're asking your machine to group your entity based on certain interests. So like, how can I group this is the key question that you're asking. For example, if you want to group users based on their interest, this is an example of clustering. So now we have identified what are the type of questions that you can ask the machine. Let's get into an example. So let's say you are a product manager in an e-commerce company and your area is risk and fraud. And you want to leverage machine learning. So a key question for you is this transaction fraudulent? So when you ask this question, when you're asking this question, you're essentially defining or determining what is the ML technique that you are using. So based on what we saw previously, we know that this is a classification problem. So with this step, you have a good start into what ML technique you will be using. So now we come to the step 3, which is all about defining the requirement. A key difference here compared to a non-ML product is that a key part of your requirement is defining the acceptable error. Let me elaborate what I mean by it. So acceptable error in the world of machine learning product is the difference between the predicted output and the actual output. And irrespective of whatever domain or whatever type of model you're using, all types of model essentially have a concept of error, which measures how well they are doing with respect to what the expected output is. Model error essentially measures the quality of your model. The exact definition of the error depends on the model type, and we'll look into one example later. But conceptually, error would be the difference in the predicted and the output, and the actual output. And why is it important? It is important because the model error impacts the goal metric, which is the most important thing for you to begin with. Let's get into an example. And let's use our fraudulent example. So for fraudulent, as we saw, it's a classification problem. And the two key metrics for error here are precision and recall. The precision measures out of all the transactions that our model has classified as fraud, how many of them or what percentage of them are actually fraud. Recall measures out of all the transactions that are actually fraud, what percentage of them were caught by the model. So together, precision and recall measures how well of a job your model is doing in identifying and classifying fraudulent transactions. So as a product manager who is working on a classification problem, it is very important for you to not just understand the error metrics, but also define what the right range for these error metrics should be so that you can meet your goal. So for example, in this case, when you build a model, you see that the precision and recall, both of them would increase to a certain level. And after that, there is a trade-off between the two. So if precision increases, the recall would decrease and vice versa. And now what does this mean from a business perspective? It means that you have to make a trade-off between classifying a non-fraudulent transaction as a fraudulent transaction or missing out on actual fraudulent transactions. And that is a call that you have to take as a product manager and as a business person. Now that we've covered acceptable error, let's look at some other considerations that should go into the requirement of a AI and ML product. So we have privacy and trust. It is well established that data is actually the front and center of your model. And because that is the case, you need to be very careful about how the data is being used, what data is being accessed by your team members, and what is the impact on the customers because of that. And depending on the use case, you'll have to partner closely with the legal to make sure that you are complying with the local regulations if you're launching something internationally. And you may have to put some governance process in place to protect individual customers' data. And you'll have to use data in an aggregated fashion that doesn't violate individuals' privacy. The next point here is about the end-to-end user experience. So remember we talked about the LinkedIn messaging, right? Imagine if instead of 3 options in smart replies, it presents you with 10 options. Will it then really reduce the cognitive load? As a user, I may think of just typing my custom reply as opposed to choosing and investing my time going through all the options. The other example is, let's say you are doing grocery shopping on Instacart, and right before you place an order, you're presented with 20 other product recommendations. This is where the user experience is important. So as a product manager for an AI and ML product, it's not just about your defining your goal metric and building a model, but also about how you're defining the user experience, like any other product. The fourth one here is keeping in mind what is your requirement around the runtime prediction and pre-compute. So for example, if you're a product manager at Shopify and you're building a system to identify fraudulent transaction, it is in the interest of your merchants to get notified if a transaction is fraudulent before they ship the item to the customer. So there is this time duration that you need to keep in mind, and your prediction should come within those time duration thresholds. So you may not always have to have a model that predicts in real time, but you need to understand what are the boundaries and threshold in which your model has to make those predictions. So you will have to work with your engineers to implement a pre-compute or a runtime prediction strategy based on this requirement. The next one here is the degree of explainability. Explainability or interpretability essentially means being able to explain why the model predicted something that it predicted. And this concept has gained popularity recently for 2 reasons. One is knowing why something is predicted would help and add more insights, give more insights so that we can make the experience better for the customer. And the second reason is AI and machine learning is gaining more adoption in the world of B2B, where we have to make things more transparent. And due to these 2 reasons, explainability is a factor that you should consider when defining your requirements. The next one, or the last one here, is the feedback loop. Now, feedback loop is nothing new. But the thing to note about feedback loop in context of ML product is that you should know whether the feedback loop data is core data to train your model, or it's something that's a supplemental data to further improve your model's performance. If it's the core data, that's something that you have to build in the MVP, or you have to treat it differently in terms of prioritization. So do make sure that you look at feedback loops in your requirements. Let's get to step 4, which is about teaching your model well. In other words, it's about building your model. So before we do that, let's talk a little bit about how machines learn. So there are 3 ways. First is supervised learning. In this case, your machine expects a set of input and a set of output. And based on that, it will create a model that would, in real world, take unseen inputs and predict the relevant output. Next type is unsupervised learning. And in this approach, it still needs data. Your machine needs data. However, it doesn't need the output or the label data. It only needs the input data. And from that, it figures out the hidden patterns to solve the problem. The last approach is reinforcement learning. And this is based on rewards and punishment mechanism, where your model would take a certain moves. And if the moves are right, it will get rewarded. And if not, it will get punished. And based on that, it will learn and choose to maximize the moves that will reward it. So these are the 3 ways the machines learn. The example that we discussed earlier about LinkedIn messaging and the smart replies, it is based on supervised learning, where it takes the finite number of messages from the historical conversations between the users on the platform. So it has the input message as well as the responses that happened or that were done by different users, and uses these input and outputs to create a model that would then predict those smart replies. Now, be it any type of learning method, data is at the center. So for data, there are certain things that you need to consider while you're building the model. So for example, where the training data will come from, what is the quality. You also have to look at how the data is selected for the training purposes and whether or not it is free of bias. For example, if you are in an e-commerce company, the holiday season is, the sales in the holiday seasons are skewed. So you don't want to take the holiday period data as something that is a representation of your real data throughout the year. The second thing is about the data cleaning and exploration, and this is where you have to partner closely with your data scientists as they analyze different inputs and the relationship between them and the relationship between input and output. The last thing is the feature engineering. This is again where your data scientists would need help from the experts, the experts in the domain. For example, if you are working on a marketing problem, the inputs from the marketing team would help to make sure they're not choosing a feature that is not relevant to the problem space. The next step when you're building a model is the algorithm that goes into it. And this is where you have to lean more on your data scientist. Just to give you a reference, these are the popular algorithms that are used. And one algorithm can be used for different ML techniques. For example, decision trees are used to solve regression as well as classification problems. Now we come to the last step of the 5-step framework, which is evaluate and deploy. So when we evaluate, we are looking for two things. One, is the acceptable error requirement met or not? The second, does this product or feature drive the goal metric that we initially started with? For the latter, I suggest you use the experimentation techniques that we use for non-ML products as well, like A/B testing. But I would talk more about the acceptable error testing. So when you have the output of the first model, you will be looking at the error metrics that you have initially defined in your requirement. For example, if you have precision and recall as your error metrics, you would have set up success criteria like the precision of the model should be 95% and the recall should be 80%. Or something along those lines. So the first thing that you evaluate is whether those requirements are met or not. If they are not met, there is a concept called model tuning, which is where your data science team will help you to change some parameters in the model, and these parameters will depend on the algorithm that the model uses. For our understanding processes, we can think of it as some sort of weights. So they will change those weights and those variables in order to improve the error metrics. So there could be a couple of iterations that happen, and you should always have a baseline model and improvements on top of it so that you know how much improvement you've made. So that is about evaluation. The next step, once you meet the error requirement, you should be thinking about deployment. And deployment essentially means how do you integrate your model into the production environment so that it's scalable and it really starts benefiting your customers. So when you think about deployment, you should think about whether this model is going to be deployed once, like one time, or it has to be continuously trained and refreshed at regular intervals. You should also be thinking whether you will pre-compute the output and store it in a place and then make it available to the downstream systems. Or this will be a real-time model that will make real-time predictions. And your deployment strategies would really depend on that. And this is where your engineering team would come into picture. Now that you have an understanding of end-to-end life cycle of a machine learning product, I want to get into a little bit more nuances. And I think this will help you to make sure or increase the chances of your success when you go out there and actually build your machine learning product. So right after you have defined your requirements, it's a good idea to reassess if machine learning and AI is the right fit for your use case. And I suggest you do this by asking 4 questions. The first is around data. So you should ask how easily the data is available, the data that your model requires, and what is the cost of it. There are a lot of use cases where the data is available. It may be in different destinations and you have to bring it all together, clean it, but the data is essentially there. So for example, if you are building product recommendations that are powered by users' historical views and purchase, this data will be there with you. But if you're working on a voice assistant system like Alexa, you need the word by word transcription data in different languages. And this is something, it's not implicitly generated by users. This is something that you have to employ some human annotators to generate it. So look at your use case and understand what is the data that you need and where is it going to come from and what is the cost. Because this will allow you to make a better call on the return of investment that you're going to get with your initiative. The second question is, what is the degree of explainability that is required? And we talked about it earlier as well, but this is a time where you can reassess because now you have done detailed requirements, you would have spoken to different stakeholders, and you'll have a clearer picture on whether explainability is a deal breaker for your product or not. And if it is, and if you need 100% explainability, maybe machine learning is not the right path for this idea or this product. The third is, what is the cost of incorrect machine output? And by this, I mean, if you have defined your error percentage to be 5%, for example, what is the implication when the error happens? Is it just that we lose a sale, or is it like someone dies? So you need to understand what is the implication or the cost of an incorrect output and the risk associated with it, and then take a call whether machine learning is the right solution or not. The last one is your use case a unique use case in the industry, or it is something that has been done by other competitors or someone in different domain? Because if others have gotten success with it, it should give you a little bit more confidence, especially in terms of like tech feasibility. That it is something that should work out. So I suggest you look at these four areas to make your final decision on whether or not you want to continue with machine learning or not. Now that I walked you through the 5-step framework to build and launch AI and ML products, I want to take some time to walk you through some AI and ML concepts that you should know about. Now, we have covered some of them in the previous slides, but we couldn't go into details for all of them. And I wanted to create sort of a go-to place for you so that you can look at all the concepts that are important to learn and go dive deeper at your own time. So we'll start with the first one, which is how do machines learn? And this is where we learn about the supervised learning, unsupervised learning, and reinforcement learning. And we also saw some examples like LinkedIn Smart Replies that uses supervised learning. The second concept that you should know is the ML techniques. And here also we saw 4 ML techniques that you can determine based on the type of questions that you want to ask the machine. So we have regression, classification, detection, and clustering. And I think the example that we saw today with the fraudulent use case is of a classification. The next concept is the model errors, which are a key part of your product requirement. And we saw that the less the model error is, the better it is to drive your goal metric. And we dived a little bit deeper on the precision and recall with the fraudulent use case. We understood the relationship between precision and recall, and that it is required of a product manager to define the acceptable ranges for precision and recall for their products. On the right, you'll see mathematical definitions of precision and recall. This is very important if you're working on a classification problem. The last concept is about the machine learning algorithms themselves. And a key distinction between machine learning algorithms and model is that we use the algorithm that eventually creates a model. So you could, for example, you could use decision trees, which is a kind of algorithm for multiple problems, but each problem would have its own model, its own unique set of features. But the underlying algorithm that is used is going to be decision tree. So in this case, for this concept, it's not required for product managers to really understand how these algorithms work. It's good to know, but this is a place where you should lean more on your data scientist and go in with your requirements to make sure that the algorithm is creating a model that meets your requirements to best serve the customers. With that, we come to the last part of my talk, which is where I want to inspire you to take action today to get started. I ask you to do three things. The first is think about your goal metric and create a hypothesis around it. The second, frame the key question for your AI and ML system. And the third, define the acceptable error portion of your requirement. If you want feedback, feel free to share this with me and tag me, and I'm happy to respond. Thank you.